Yeah, it definitely is going to faster. As soon as you can bring on the same car a little bit
Just
earlier.
my quick 5 minutes here. I want to thank Rick and Freedom Technology for inviting me, and thanks for you folks for listening to me. I've been in the laser industry close to 30 years now, and there's going to be a quick 5-minute primer on what we do and how we do it differently than other people. As you guys know, the difference between a YAG laser and a CO2 laser, the primary difference is the wavelength. The YAG light is about 1 micron, which is real close to visible. The CO2 laser is 10 microns, which is infrared, further away from visible. In the real world, what that means is that with a YAG laser, you can focus to a tighter spot. And typically, the YAG laser is around 1,000th of an inch spot size. A CO2 is typically 5 to 7 thousandths of an inch spot size. And if you look at the Domino or the Videojet laser, I mean, you can actually see the spots. With the Universal, one of the things Universal brings to the game is a patented optical system. We call it the high power density focusing optics, HPDFO, and it reduces the CO2 beam to about 1,000th of an inch. That means when you're looking for a small cell, like a 5,000th cell in your 2D code, Domino can't do it, Videojet can't do it, but we're putting down actually 5 by 5, 25 dots to make a 5,000th cell. So we have the control and the ability to do that. We talked yesterday about an analogy here. Imagine driving down the road with a bucket of golf balls and trying to throw them out of your car to make a series of lines that make sense to the barcode reader. Well, that's what we're doing here. We're moving the optics back and forth and putting down dots. That's all we're doing. Our dots are 1,000th of an inch versus the bigger dots there. That's why we get the higher resolution. That's also one of the reasons that this laser is slower than the other lasers, because they're working on a 5,000ths or 10,000ths resolution. We're working on 1,000th of an inch resolution. Now we can change things and go faster, but then you lose the precision that you need with the UI. So
Also, you're using a belt, and these guys are using
galvos.
right galvos to bend the beam and move it around.
Which brings us to the software, another advantage that we feel we have. We're working everything in linear X and Y coordinates. The Galvo systems, they're actually twisting mirrors. So they're going from some sort of information going through a polar coordinate system and then generating a image down on the workpiece. That's the reason that they like to use their own controller and their own proprietary software as opposed to a simple print drive. So, I mean, Jim will tell you, yesterday we came in and we set it up and we were making good, readable UID marks in 15 minutes. Whereas working through the controllers, you have a distinct disadvantage. So,
Good readable grade A.
yeah, they were great.
Grade A, validated. Excellent marks. If you just look at it, look at the difference. We're marking on wood. If you just look at the difference, I mean, that's a very good quality mark.
So, Universal also makes a similar system with a YAG. So, the advantage there is that you have the ability to mark on other than stainless steel and aluminum. Because this high power density focusing optics will put a dark mark on stainless and it'll mark the aluminum tabs. It'll also mark plastic or labels if you have that. But with a YAG, you then have the ability to do tool steel and other metals. Some other, what I consider advantages of Universal Laser is, number one, it's made in America. Everything is made in Scottsdale, Arizona. We've got about 75 employees. We don't contract out the software. The print driver is done by our software engineers. If you have a problem, you can talk to the software engineers that actually write the code for our print driver. The same is true of the guys who actually build the laser. The light bulb inside the system. We build that in Scottsdale, Arizona. If there's a problem, you can talk to the guys that design it, you can talk to the guys that actually put it together. And we kind of emphasize the philosophy of keeping it simple. That also means keeping it inexpensive. To operate our system, of all the worldwide manufacturers, we have the lowest cost of ownership. Typically, our systems are about very competitive price to purchase, but to operate them, the spare parts are very inexpensive. We average a couple years between major services, and by major service, we're talking about 15 minutes worth of service. So we have customers that will run 5 to 7 years with virtually nothing more than routine maintenance. So that's kind of.
And is that what the ATA 2000, are they applying ATA 2000 to the data matrix with the equipment?
Yes, some of them are.
For 7 years you've been doing it?
No, the ones I know of have only been doing it for 2 or 3 years. But direct part marking and other applications for 7 years or more.
I'm just trying to understand if the accuracy stays for extended periods of time, because that's a concern with the belts.
It's a very important concern with the belts. And it brings up a point that you brought up before with the lead screw. Universal Laser uses a cog belt and stepper motors. It allows us to tell the laser to go to a specific position and put down a dot. Other people use encoders and servo motors. And the problem we have found, because we've done the testing there, is that when you're accelerating, go back to the automobile throwing out golf balls. If you're accelerating from 0 to 100 miles an hour, trying to get those balls spaced so many inches apart, it's really hard to do. But with a stepper motor, we get to the speed and we know exactly how many steps between each ball. So we can be very, very accurate with our marks. Now, over time, the belts tend to stretch. They are Kevlar reinforced, so they're pretty stable. But we have a software compensation that allows you to scale that over time. So we have a calibration capability built into the machine. No one else offers it. Everybody else, when the drive system starts to wear, you've got to replace the drive system, and you're talking about $2,000 to $5,000 to do that, plus a technician from the factory to do that. For us to replace the entire drive system, you're talking about under $1,500. And like I said, we've got customers that go many, many years without ever having to do it. So we've designed and built it with a low cost operation. I don't know. I hope that answers any questions.